Hello and welcome, as ever, to another exciting edition of Maths with Mr. Thompson. And today we're looking at trigonometry of triangles which are not right angled. And the first of the main rules that we look at with these triangles is something called the sine rule. The sine rule. Now, I'll just state what the sine rule is. It basically just says that for any side A, if you take the sine of the angle opposite, then that ratio is going to be the same as for any other side in the triangle, say B, and the sine of the angle opposite it. And that works also for the third side, C and the angle opposite it. So that's it, that's basically the sine rule. There's these three things, these three pairs must maintain the same ratio. Now, depending on what we're looking for when we're using the sine rule, we can actually use, if we want, this format. Nothing is different, it's exactly the same in terms of its values. All we're doing is we're trying to make that next step in the calculation a little simpler, and we'll see a couple of examples of that in a second. The most important thing to bear in mind here is that you must name your sides correctly. The convention is that the angle has a capital A and the side opposite must be the small a. If that isn't the case, then none of this will work. It will all be abject nonsense. So you must make sure you name your sides correctly. Now, really the only thing you can get wrong with this is not naming the sides correctly. Or else it may be that you have your calculator in degrees or radians and you got them the wrong way around. So make sure whatever the problem is posed in, that you have your calculator set in that mode all the way. The rules work regardless of degrees or radians, but you must maintain them consistently throughout the whole solution. Let's look at a couple of examples. Here's one here. We're trying to find the length of this side x. Okay, so it's a classic situation to bring in the sine rule, because we've got a side and we've got the opposite angle there, and we've got an angle and it's the other side that we're looking for. This pair here, C, is not involved. We don't need them, they're not part of the process. We're only looking at those two we have got. So let's just dive in here. We know that x divided by the sine of the angle opposite, which is sine of 43, must equal 5 over the sine of 58. Okay. Now, with a little bit of algebraic rearranging, and how you can think of it is you can take this and you swing it up here, is one way of looking at it. Technically, you're multiplying both sides by sine 43, and then it's cancelling out. So what you end up with is x, excuse me, I just changed my colour, x equals 5 times the sine of 43 divided by the sine of 58, and you get an answer there of x equaling 4.021 centimetres. And that should make sense, because if you look at the actual original triangle, 58 is slightly bigger than 43. So we would expect that the side opposite to be slightly bigger than x. So we've got 5 compared to 4.021. So that answer, that makes sense. Happy with that one. Okay. So that's an example of using the sine rule to find the side of a triangle. What about if we're asked to find an angle? Here's one here, we'll try to find theta, and again it's a classic sine rule situation. We've got one side and the angle, and we've got another side and the angle we're looking for. But this time we're going to use that flipped version of the sine rule just to make it a little bit easier. In the flipped version we can put the sine on top, so sine theta over the side opposite, 10, equals sine 72 over the side opposite, which is 11. Once again, we can bring this guy up here, swing it over, which gives us sine of theta equals 10 sine 72 divided by 11. So theta equals the inverse sine of all of that. That gets you a value of theta of 59.8 degrees. Now, just as a wee bonus question, if you're actually asked to find this angle here, and you found theta, you can find this one by going 180 minus 72 and minus 59.8. Do it that way. Use the three angles, add up to 180 rather than going from the sine rule again. Okay, there you go. The simplest way to use the sine rule.